Hey guys, so we're going to go over the more Punnett Square practice that I assigned on Thursday and Friday. Please make sure you review and correct your papers so that you are prepared for Tuesday and Wednesday when we begin our incomplete dominance and codominance Punnett squares. Okay, we need to have a really strong understanding about this. Alright, so we did number 1 in class, in all of the classes. We had some technical difficulties in 6th period, so I'm going to start with number 2 on here for the video. Quick reminder, whenever we are talking about genotypes or phenotypes, please make sure you, and ratios, list things in the same order every time. You always start with the homozygous dominant, followed by the heterozygous, followed by the homozygous recessive. So we're always talking about it in that format, okay? Alright, so we did number 1 together, so we're going to go straight to page 2. And for those of you that we already did this in class, just go ahead and wait, fast forward if you want to get to the next one. Okay, so in dogs, there is a hereditary type of deafness caused by a recessive gene. 2 dogs who carry the gene for deafness but have normal hearing are mated. What are the possible genotypes and phenotypes of their offspring and the percent chance for each? So first thing I'm going to do, I'm going to write down what my alleles are. So big D is normal hearing. Little d is deaf. And then I'm going to write my P1 cross. We have 2 normal hearing dogs who carry the gene. So that means they are heterozygous. So we go big D, little d times big D, little d, which we knew because it was already listed here for us. Alright, first thing we're going to do for our Punnett square is drop the big D's down to the left side of the column and our little d's down to the right side so that we properly have our Punnett squares set up so that each of these is in the correct order. Slide your big D's over, slide your little d's over, okay? My handwriting looks awful this morning. Sorry guys, I guess I haven't had enough coffee yet. Sure I have, but I'm just going to use that as an excuse. Alright, our first square, our first genotype is going to be big D, because again, always start with homozygous dominant. Then our second type of genotype that we have present is big D, little d, heterozygous. And we also have a homozygous recessive, so we have little d, okay? Now we need to discuss the phenotype that these different genotypes will bring. Remember, big D was normal, little d is deaf. So we have 2 big D's, so this will be a normal hearing dog. Homozygous dominant will be normal. Our heterozygous contains that normal hearing allele, so that means it will also have normal hearing, which leaves our homozygous recessive as having deafness. So we have one combination that will produce a deaf puppy. What is the percent chance that our offspring will be homozygous dominant? So if you remember from our notes, each box indicates or represents 25% in these monohybrid crosses. So how many boxes have big D? Well, only one does. So it has a 25% chance of becoming big D, the offspring. How many of our boxes are heterozygous, big D, little d? Well, we have 25% chance here and 25% chance here. So you add those 2 up, and 25 plus 25 gets you a 50% chance of a heterozygous puppy. Lastly, we have one box that is homozygous recessive, which means we have a 25% chance of having a deaf puppy. Total, we have a 75% chance of having a normal hearing puppy. Okay? Alright. Let's go on to number 3. In guinea pigs, short hair is dominant over long hair. If a short-haired big S, homozygous dominant guinea pig is crossed with a long-haired homozygous recessive guinea pig, what are the possible genotypes and phenotypes of their offspring and the percent chance of each? Okay, so the first thing we're going to do is start with big S is short, little s is long-haired. Okay, so our P1 cross is going to be big S times little s, which makes sense because our squares here are also set up that way. So parent 1 goes here, parent 2 goes here. Now we drop our big S down on both sides on the left because both of them are capital. Slide our little ones over. Okay. Now look, we have all of them are the same genotype. So all of them are big S, little s, which is, because a big S is capital, means it's going to be short-haired. If I can write straight too. Short-haired. And the chance of having a short-haired guinea pig from this crossing is 100%. And yes, there is an extra box on there. You can just cross it off. Okay? Let's go to number 4. Can you curl your tongue up on the sides? Did you guys know that this is an actual dominant trait? Well, it is. So if you can do that, look, or that means it's dominant. You have the allele for it. If you can't do that, then you have the homozygous recessive trait. So there we go. Now you know. Okay, so I'm going to start with big T is a tongue roller. We're just going to call it roller. It's a roller and a non-roller. And little t is a non-roller. And I'm calling it that because we have a lab that we do at school where we go around and we find out how much of the class is a roller and how much of the class is a non-roller, and it's kind of interesting. Okay. Tongue curling in humans is a dominant genetic trait. Suppose a man who is heterozygous for tongue curling marries a woman who is also heterozygous for this trait. What are the possible genotypes and phenotypes of their children and the percent chance of each? Okay, so now we do our P1 cross. We have 2 heterozygous individuals. Okay. Parent 1 goes on the top. Separate out the alleles. Parent 2 goes on the side. Okay. Makes sense? Drop your big T down. Drop your little t's down. Make sure you leave room for a big letter in front. Slide your big T's over. Slide your little t's over. And there we go. We have our Punnett square. Let's look at what genotypes do we have present. Do we have any homozygous dominant? Big T, we do. So that one goes there. And we also have heterozygous, so we put that one there. We also have homozygous recessive. Boom. Okay? So, big T, is that going to be a roller or a non-roller? Well, hopefully you look above and you see, oh, big T's are rollers. This one has the dominant allele, so it will also be a roller. But our little t is a non-roller. Not that that's bad, it's just different. Okay. What is our percent chance of having big T? Hopefully, you got the one box is 25% chance. Heterozygous. What is our chances of having a heterozygous offspring? 50%. 2 boxes, 25% each. And our percent chance of having a non-roller for an offspring is only 25% chance. Okay? Hopefully that makes sense. Alright, in guinea pigs, we're doing guinea pigs again. Ay, lots of guinea pigs in this class. Rough coats with lots of swirly cowlicks are dominant over smooth coats. If an homozygous dominant guinea pig is crossed with a heterozygous guinea pig, what are the possible genotypes and phenotypes of the offspring, and what are the chances of each? So first things first, big R is, a rough coat is smooth, dominant over smooth. So rough coat. And a little r is going to be a smooth coat. And our P1 cross is going to be big R is crossing, this is parent 1, with big R little r for parent 2. Okay? So what we need to do now is put our parent 1 on top here and parent 2 on the side. Drop your big R's down. And I didn't mean to put that quite so far over. That should be more centered. That way it looks like it belongs where we're putting it. And then we slide our big R's over, and we slide our little r's over. Alright, so for this one, we will have 2 genotypes. We have big R, and big R, little r. So we have homozygous dominant, and we have heterozygous. Homozygous dominant means it will have a rough coat. Heterozygous means, because it has that dominant allele, it will also have a rough coat. What is our chances of having it be homozygous dominant? Well, we have 2 boxes that are that way, so that is 50% chance. And big R, little r, heterozygous, we also have 2 boxes, so that one is also 50% chance. And remember, the chance one needs to equal 100 if you were to add them all up. So that can help you double check and make sure that you're doing it correctly. Okay? All right, that is the end of that one. Have a good day.